All right, I'm going to work out some of the problems from the packet so that hopefully it will help you be able to work through these problems if you're still struggling with them. One of the most difficult ones that you may encounter is like number 3 on worksheet 2, where you're solving for the final temperature. So let's give that one a shot. All right, I listed out all of the given information. And the plan here, since we have changes in pressure and in volume, then we are going to use the combined gas law because that deals with changes in pressure, volume, or temperature. That's P1 V1 over T1 equals P2 V2 over T2. And in order to solve for T2, T2 is in the denominator, so I'm going to cross multiply first. So P1 V1 T2 equals P2 V2 T1. Do that to get the T2 out of the denominator. And then we can divide both sides by P1 V1. And that'll give us T2. All right. Now, when we solve, we're just plugging in the numbers that are provided here. So let's do that. So this pressure 2 was 760. And the volume 2 was, I believe, 1.8 liters. Had a little bit of trouble telling what it said there. T1 was 22 degrees Celsius or 295 Kelvin, which you need to use Kelvin in gas law problems. And then we'll divide by P1, 600 millimeters of mercury, and times V1, which was 2.5 liters. All right, millimeters of mercury cancel out, liters cancel out, leave us with Kelvin. So our final temperature will be in Kelvin. Let's get a calculator and do that calculation. All right, I plugged that into the calculator and got 269 Kelvin. And then if I want to go back to Celsius, I would add 273, or excuse me, subtract 273 from it. And that would give me negative 4 degrees Celsius, which matches with the answer that they gave. All right, I'm also going to work out a few problems here on worksheet 6. So first off, let's take a look at number 3 on worksheet 6. And so the unknown here is they ask us what pressure. And they tell us 25 grams of carbon dioxide. They tell us 25 degrees Celsius. I'm going to go ahead and convert that to Kelvin. Plus 273 gives you 298 Kelvin. Volume of 500 milliliters. And that'll end up needing to be in liters. So I'm going to go ahead and convert that as well. Now, when there's no change here. So that's our hint that if we're dealing with pressure and volume and temperature, and we're talking about a gas, then we would use a gas law, but it's not the combined gas law, it's the ideal gas law. So we're going to use PV equals nRT to solve for the pressure. So let's go ahead and solve for P. So divide both sides by V. So P equals nRT over V. Now, if we go up here and look at our known, you might notice that they give us grams of carbon dioxide. We really need N, which is moles. So we're going to convert that. So 44 grams per mole carbon dioxide. And then we'll do 25 divided by 44 in our calculator. And that gives 0.568 moles. And you might also notice the absence of R. Given that they show the answer in atmospheres, I'll use the gas constant that corresponds to atmospheres, which is 0.0821 liters times atmospheres over mole Kelvin. Okay, and so all we've got to do now in our solve is plug in all these numbers. So P equals 0.568 moles times the gas constant, and then times the temperature, 298, and divide by the volume, so 0.500 liters. All right, plug that into the calculator. All right, and that should give you 27.8, which when rounded to two significant figures due to the 25 grams, that only has two significant figures, so the moles has two significant figures, so the pressure should have two significant figures. So the final answer would be 28. All right. Next up, I'm going to take a look at number 5, which asks you to solve for the density of the ammonia. All right, and initially this question could be really intimidating, but it doesn't have to be. Density is mass divided by volume, so at some point we're going to do D equals M over V, but we may be able to find something useful from this. The information that they give us. So let's see what we can work out here. The unknown is the density, and then the knowns. So 800 towards the pressure, and the temperature again in Kelvin is 298. Add 273 to the 25. And they tell us that it's ammonia. So the formula is NH3. And we know that for NH3, that 1 mole of NH3 equals about 17 grams if you add up the molar mass. And that might just be enough information to help us do something with this in terms of gas laws. So ammonia is going to be a gas at room temperature, and unless it's dissolved in water. But if it's out free by itself, it will be a gas at room temperature. So we know the moles, we know the temperature, we know the pressure. So we can apply ideal gas law to it in this way. We do PV equals nRT. And the only thing we don't know about this gas is the volume. Now, volume would be really helpful to us if we're trying to solve for the density, because we know the mass of a mole, and if we could find the volume of a mole, then we could just do mass divided by volume, and we would have the density. So let's do that. We're going to solve for V. So V equals nRT over P. And let's come over here and do the solve part of this. So he said 1 mole is what we're going to assume that we have. And our pressure is in torrs, so I'm going to use 62.4 because that's the gas constant that goes with torrs or millimeters of mercury. And the temperature is 298. And I'm going to put that all over the pressure, which is 800 torr. Plug that into the calculator, and I got 23.2. Now, I know the mass is 17 grams, and of a mole is 17 grams, and the volume of a mole is 23.2 liters. So I'm just going to divide those. And when I divide them, I get 0.73. Grams per liter. And that matches the answer key. Number 6 on the same worksheet tells you the density of the gas, and then it asks you what is the molecular mass of the gas. So might help for us to think through this just a little bit. So molecular mass is grams divided by moles. So if we can get the grams and the moles, then we can get the molar mass. Now, they give us this information. So they tell us the density equals 1.2 grams per liter. They tell us the pressure is 745 torr. And they tell us the temperature is 20 degrees or 293 Kelvin. Now, the density can be useful to us because what this means about this gas is that 1.2 grams of the gas equals 1 liter of the gas. So here's grams. Let's figure out how many moles are in this liter of gas. So we can use the ideal gas law, PV equals nRT, to do that. Solve that for N. So it'll be PV divided by RT. And let's do our solve. And let's see, we're working with torrs. So let's do 62.4. Okay. And oh snap, I just put that in the wrong place. I caught that because I was paying attention to the unit, and I knew that if I had moles in the denominator up here, that it wouldn't end up being the final unit. So I looked again, and I realized, hey, I'm supposed to put the pressure up here. So let's do that now. 745 torr. And the volume, we said we're going to figure out the number of moles in this 1 liter. So we're going to do 1 liter, and then R, and then T is 293. All right. So let's plug that into the calculator. And I get the number of moles is 0.0407. Now, remember, molar mass is grams over moles. So we just figured out that 1.2 grams has a volume of 1 liter, and then we use the ideal gas law to figure out that 1 liter contains 0.0407 moles. So we can just divide those to get our grams per mole. So 1.2 divided by 0.0407, and I get 29.44, which we will round to 29 because 1.2 only has 2 significant figures.